Okay, ladies and gentlemen, we're talking 3-4 direct variation. It is a pretty simple thing here. Hopefully you guys will find it as simple as I think that it is. So make sure you get into your notes that direct variation equation are in the form of y equals kx. That is a super important thing where k can never equal to 0. So k refers to a few different things. It's called the constant of variation, the constant of proportionality, and slope. So all three of these things are the exact same thing if it comes down to are they the same or different. So k is slope. And we found out slope last time. So what makes a direct variation equation special from any other equation? And why is it so special? It's because this one simple thing. It always goes through the origin. So the equation will always go through the origin. Now I'm going to pull this to the side here. What is the origin? Well, the origin is 0, 0. It's where the x and the y axis intercept. So that's something you guys probably already knew, but we're going to quiz you anyway. Alright, so these are 4 examples of direct variation equations. I want you to notice that each one of these equations goes through 0, 0, and sometimes they have a positive slope, sometimes they have a negative slope going down to the right. But they always go through 0, 0. So if you have a graph, you can identify it as a direct variation equation or a direct variation graph based off of the fact that it goes through 0, 0. Now, when we have a constant of variation or the slope of the line, we're trying to use that information. The slope of the line and the constant of variation are always the number in front of the x, or in our direct variation equation, it's the k. So the number in front of the x is the k, so in this case my constant of variation is 2. So my k equals 2 and my slope equals 2. Slope is also known as m, so all these things mean the exact same thing. So slope equals 2, k equals 2, m equals 2, they're all the exact same thing. So if we had to have a point of 1, 2, and it's going through 0, 0, we had to go up 2 to the right 1 to get there. So these are a few word problems. Our job is to say, do they make a direct variation equation? So if you want to order pizza, each pizza costs $7, but you have to pay a $2 delivery charge. To me, that looks like this equation. Y is equal to $7 times the number of pizzas plus a $2.50 delivery charge. Now because this does not come into the same type of form of the y equals kx, it is not a direct variation equation because this is going to change it so they're not very proportional. If I got 2 pizzas, it still wouldn't cost me 2 pizzas times 7. It wouldn't be $14 per pizza. It would be $14 per pizza plus the $2.50, which changes how much it costs per pizza. If you are babysitting and you earn $8 per hour, if y is the amount of dollars, k is how much you make per hour, and x is the number of hours, this is the equation. So this is definitely a yes, a direct variation equation. It's exactly what the y equals kx form is. You and 6 friends go to Valley Fair. It costs $30 for each person to get in and $10 to park. This and $10 to park changes it to being not. So this is not a direct variation equation. This would be y is equal to $30 times the number of people plus $10 to park. So that changes it out of our form of y equals kx. So those should be quick and easy. Now, in this example, we have 2 steps. One, part A, is to write a direct variation equation that relates x and y. So we're going to use the information. They gave us an x and they gave us a y. So into the y equals kx, we plug in our y and our x so that we can figure out what k is equal to. So when we do this, in for y is a 9, k is still k, in for x is a -3. So in order for us to get the x or the k by itself, I have to get rid of this times a negative 3 by dividing by a negative 3. So when I divide both sides by a negative 3, I'm left with k equaling to a negative 3, which means part A, my answer is y is equal to, in for k, I put this negative 3 times x. So that's my part A. Part B says plug in y equals 15 to figure out what x equals. So we're going to find out what x is when we plug in y is 15 to this equation. So 15 is equal to a negative 3 times x. And when we do our work, we're going to again divide by a negative 3 to get x by itself, which means that my x is equal to, so for part B, x is equal to a negative 5. And these are then my two answers when they're asking me to solve these types of problems with a part A and a part B. You just do exactly what they say. Plug them into the direct variation equation. Let's try that one again. So suppose that y varies directly as x. That's when we're using our direct variation equation. And then what we're going to do is plug in x and y. So 15 is equal to a k times 3/4, and then we're going to divide both sides by 3/4, which means that we're going to actually multiply, because when we divide fractions we multiply by 4/3 or by the reciprocal, so those cancel, times 4/3 on this side as well. So we're left with k is equal to, let's see, 4 times 15 is 60. 60 divided by 3 is 20. K is equal to 20. So my part A, we're going to plug k equals to 20 into this original y equals kx. So y is equal to 20x. And now part B, we have to do the work. Part B says find x when y equals 25. So we put a 25 is equal to a 20 times x. So we divide both sides by 20. And we find out that since 25 and 20 can be reduced, part B, x is equal to, divide them both by a 5, and we get 5/4, or 1.25. So those are my two answers. This is how you solve direct variation equations, folks. Use this video to help you out. This is what the equation we will be working, or the assignment we will be working on in class.